will continue. A and B below are two identical blocks, each with a mass of 5 kilograms, joined together by a light inextensible string. The blocks are being pulled with a force of 65 newtons at an angle of 40 degrees to the horizontal. So here's our blocks, 5 kilogram. A and B are two 5 kilogram blocks with a mass, and there's a string that's pulling them. The blocks are being pulled with a force of 65 newtons at an angle of 40 degrees to the horizontal. The two blocks accelerate to the right at acceleration of 2,17 meters per second. And the tension on the rope is 26 newtons. So this basically explains this whole diagram. It is being pulled at an angle of 40 degrees to the horizontal, 65 newtons, and we've got two blocks of 5 kilograms, and there's a force of 26 newtons between the two blocks. Calculate the friction on each block. So to do a sum like this, what we'll have to do is draw the forces of draw the force diagram of each block and then work from there, right? So we look at force A. If you look at force A, the forces acting on it directly are 26 newtons pulling it to the right, and then it says there's friction acting, and friction acts opposite to the direction of the motion. We see that the boxes are moving to the right, so the blocks are moving to the right, so there'll be friction moving to the left. So let's draw the force diagram for block A. So maybe I should just delete this. So we'll make this 2.3. So here's our block, block A, and here we'll have block B. If you look at block A, there's a force of 26 newtons pulling it to the right, and there's a frictional force pulling it to the left. So if we have to work this out, we'll say F net is equals to MA. And we know that the mass of the block, they told us that the mass of the block is 5 kilograms. And the acceleration of the block, let's just double check that. 2.7, we just said 2.7, let's just have a look again. 2.17, just double check. As I said, 2.7, we make a silly error and you lose marks for nothing. So 2.17 and the block is 5 kilograms. So let's get back here and we'll see that the acceleration is 2.17, and your net force will be the force that's applied, so it will be 26 minus the force of friction. Alright, and if we have to take it from here, if we have to work it out, we'll have to see that 5.5 times 2.17, and then if you work it out, we'll have to work out the frictional force. 5 times 2.17, let's just work that out. That'll give you 10.85. And then this will be 26 minus F, no? Correct. 26. And if you work out F looking at this, we'll get the F here. If you take F on this side, and if you take 26 minus 10.98 on the other side, we'll get our answer that we are looking for. So it will be 5 times 2.17 will be 10.85, and then the minus F will come that side, the 26 is on that side, and then 26. Fifteen comma 15 newtons. 15. Okay, so that's our first answer that we've got. And then if we're looking at on the other side, we see that we have a different case. Here we've got an angle. Oops. Let's just fix that up. There's an angle of 40 degrees, and then there's a force of 26 pulling it back, and then there's also a force of friction as well. So if you have to write down the F net is equals to MA for the other side, F net is equals to MA. But before I go here, actually, I'm jumping the gun. Let's look at our question again. It says calculate the friction on each block. So okay, yes, so we have to do this as well. So we have to work it out on each block. So looking at this case, F net is equals to MA. So here's our applied force here. Our applied force is, it will be, if you have to put the dotted line here, it will be basically, if this is 40 degrees, this angle here is 40 degrees, and then this is your adjacent side, it will be cos of theta. And then if you looked at it, we see that the 65 newtons is the applied force. So it will be 65 cos theta will be your applied force. So if you write here, it will be, your net force will be 65 cos 40 degrees. So that's the applied force to the right. And then the force in the negative direction will be minus 26 minus the frictional force will be equals to the mass, which is 5, and your acceleration, which is 2,17. So if you work this out, 65 cos 40, if we have to work it out, 65 cos 40, let's just do that. So let's say 65 multiplied by cos of 40, it gives you 49,72. 49,72 minus 26 minus F is equals to 10,85. And then if you take everything onto the right, if you take the F onto the right hand side, our F is here. And if you put everything else on the side, it will be 49,72, or sorry, 49,79. 49,79. So it will be 49,79 minus 26 minus 10,85, and that will give us 12,94. 12,94 newtons. So that will be the way we will work out the answer using calculations, so that we don't make any mistakes. 12,94 newtons. So that will be our answer for 2.3.2. So just be careful how you lay it out. Maybe you should lay it out one below the other. This will have been 2.3.1, and this will be 2.3.2. Although it would be better to lay it down below each other instead of next to each other. Okay, then no, that was 2.3.1 again, you see, mistake. This will also be 2.3.1, put it together. 2.3.2. Explain why the frictional force on the two blocks differ. Okay, why do the frictional force on the two blocks differ? We see that in this case the applied force is horizontally, and in this case the applied force has an angle of 40 degrees. So what we can say is that, if we have to write it down, what are the points that we can say there? 2.3.2. We can say the frictional forces differ. We can say they differ because they are applied at different angles. Fk equals to Un, and we can say so the force on the normal force, rather we should say rather, so the normal force on the first block is smaller than on the second block. Okay, that's very important, that the normal force on the first block is smaller than that on the second block, and because of that is smaller than the second block, because the normal force is less. So the normal force on the first block is smaller than that on the second block, thus its frictional force will be smaller. Okay, so more or less to that effect, you can say that. What's important is when you write an explanation, it is important to relate it to some scientific equations, so that will give some scientific reasoning for your answer. Okay, we will continue with question 3.